welcome back to the Python programming series. In the last video, we took a look at the print function in Python and commenting, as well as the main primitive data types that you deal with in Python, i.e. strings, booleans, floats, integers, lists, and tuples. So you see here that I have put in parentheses the symbols that represent each data type, each main primitive data type in Python. So str refers to string, bool for boolean, float for floats, int for integers, list for lists, and tuple for tuples. Okay, so we're going to start now that you know those symbols. That will come in useful for casting, which we're going to do in just a few moments, but we'll begin with something called concatenation. Now, what concatenation is just adjoining strings, specifically strings. So this can be best exemplified in an instance where we can initialize a random variable a. And a side note on variables, something very important in Python is that unlike in other languages, you do not have to explicitly initialize the data type of the variable before actually naming it, since the Python interpreter already identifies each one using quotation marks in terms of strings, decimals for floats, and other distinguishing factors. So we're going to initialize a to just a normal string name. Now that a holds the string value name, we're going to concatenate that in the print function. It doesn't have to be in the print function, but in this case, we are just going to do this. Now, this print function we learned in the last video. So if you don't know this, I recommend you check it out on the video that I posted last. All this does is just prints text or whatever you want to the console down here. But even then, I still strongly recommend you go watch the other video, then come back here, since that'll give you a better understanding of other stuff as well. So back to this print function, I'm going to type the string hello and space and concatenate it with a. And so from this we can expect hello space, and name, since that is the string value of the variable a, to be printed into the console. So we can check that. If you're using the PyCharm IDE, you can just use the run button in the top right hand corner of the IDE. Otherwise, you can just go in your navigation bar and probably find a run and just run it from there if you're in a different IDE. And you can see that we have the output we expected, hello whitespace name. Now, whitespace is just a term we use in programming. It's basically just a normal space, and that just increases readability, and it just produces better code. So moving on from concatenation, which is just adjoining strings, that's how you can think of it. We can go on to casting. What casting is just converting a value from one data type to another. So this can also be seen in the instance where we can initialize the variable b, and we can create a floating point number. Again, that's just a decimal number with a 6-point decimal precision. So let's just say 7.6. B now holds the floating point value of 7.6. Easy as that. And let's say we want to convert this floating point value, which is held in B, to an integer instead of a floating point value. You don't want to change B itself, but that's what casting is. You don't change the initial thing, it's the initial value itself. You create a replica of it. And you'll understand what I mean in just a moment. So let's say you want to convert this, cast it, to an integer, from a floating point number to an integer. So this is where these symbols come in useful. Okay, so from float to integer, since you're converting, you're casting to an integer, you want to specify the symbol of the data type you want to cast value to. Now, these parentheses are very important since this indicates a function. Any type of function, it can be a method, and we'll get more specific about that as we go on. But for now, just think of a function or method. They're basically the same thing as just a long set of, it doesn't have to be long, but it's just a set of instructions that can be called. Okay, so these parentheses indicate that you're calling a function or method. In this case, it's just a function, a built-in function. And the parameter that goes in here, parameters are just inputs that some functions need to operate and perform whatever they need to. In this case, we only put the value that we want to cast to the data type outside of the parentheses. And from here, we can print B, because that's what has been casted. Now, what do you think will come down here into the console? Well, it's not 7. It's actually 7.6. Just a side note that when uh, when floats in Python are casted to integers, it is not they are not rounded anywhere. Their decimal value is just simply dropped. It is ignored. So the reason 7.6 was printed to the console and not 7, since that would be the casted version of b to an integer, was because we didn't reference this as any value. We just printed b itself, which is just this, not any casted version of it. So we can name this cast C. I'm just going in alphabetical order, so for simplicity's sake, A, B, and C, and so on. So now we can just print C instead, which is the casted version of B, a floating point value to an integer, and we should get 7. There you go. Okay, so that's simple enough, casting just value of one data type to another. Now, before we move on, just remember that there are certain exceptions and limitations to casting. So, for example, strings cannot be casted to the integers or floats or anything like that. They cannot be directly casted to them, nor bools or anything like that. So just remember those types of exceptions and limitations, because even those minor issues or slip-ups can cause major errors in larger programs. So moving on from casting, we can talk about receiving user input. But even before we do that, let's talk about something called string methods. All that string methods are, well, to understand string methods, you just have to understand the concept of methods. Methods are basically just functions under a bigger category, which are called classes. In this case, the class is a string. Once we get into object-oriented programming even more, just more from here, you'll understand what classes are and methods, but all you have to all you have to consider them for now are just functions, so sets of instructions that can be called under a larger category. In this case, this larger category is a data type, and that data type is a string. So from here, we can, whatever we do, we're just gonna put that in a print function for now. And this dot after the A means that we're trying to access something within the string A, because remember, A holds the string value of of name. Okay, the string value name. So we're trying to access something in that string, or an attribute of it. Whenever you put a point or decimal, that usually means you're trying to access an attribute of it. So here we're trying to access a method of it. That's an attribute of it. So in this case, it would be dot upper. So what this does is just converts all the characters in the string to uppercase. And if there is dot upper, then there must be a dot lower, and you would be correct for thinking that. So this would convert all characters to lowercase instead. And we can see this in the console. You can see that the string value of name, the string value of A, sorry, name, has been all capitalized here and all lowercase here. So moving on from that, on just a side note, I'm using A consistently since that maintains simplicity and reduces computational cost, since we just need a string, nothing else. Okay, so moving on from those string functions, there's another one called .title. And remember to include the parentheses after all of these since they're methods, which are also functions. And .title, all it does is just capitalizes the first, capitalizes the first letter, first character is more accurate, of each word in a string. Okay, so that's all it does. I'm not worrying about spelling too much right now. Yeah, so that's what it does. We can see that in the output. The n of the string value name has been capitalized. Since if you know title formatting, you would know that all of the first letters of each word in a title, of each significant word, are capitalized. But in programming is just every single word's first letter or character is capitalized. So moving on from .title, there's also another called .index, and this doesn't. This takes in one parameter actually. Unlike these that take 0 parameters, uh, this one takes in a parameter, and that is a string. Since we're talking about a string in this case. Now, .index can also be used for lists and tuples, but right now we're talking about strings. So the parameter in here would actually be a string. Unless you would also have a list of strings or tuple of strings or anything like that, then it would still be a string. In the case here, we're going to put a character that we're trying to find, trying to locate the index of, and I'll explain index in just a moment. We're trying to find, we're going to specify the character we're trying to find the index of in the string, since the string specified is A. So we're going to look for the character N. Okay, so we can run it, and we see we got 0. What does that mean? So to understand index numbers, you have to understand that index numbers start from 0. This is just a way of naming the relative position of any element in a sequence of data or set of data. So what that means is that, for example, the first element in a set of data, our set of data in this case is just the letters in the string name. N would correspond to the index number 0, A would be 1, M would be 2, and 3 would be E. For example, if we looked for A, we would get 1. See? Down there. Okay? So index numbers shouldn't be that difficult. They just it's just a regular counting, but starting from 0. So there we go. Moving on from that string method, there's also another called isTitle. That can be called, and it requires no parameters. It just if the checks if string is formatted as a title. Okay, and again, the title is just every first letter or character of each word in a string is capitalized. And a dot, well, a is just the string we're dealing with here, so it doesn't really matter. And so dot, there's also dot is upper. Now that checks if the string is if the string's characters are all capitalized. And there is a corresponding function, just the opposite. That's slightly oxymoronic, but there you go. Is lower. Again, place the parentheses right after, since it is a method, which is a function. And that checks if strings characters all lower case. Okay, so that's what those string methods do. Keep in mind that these are not all of the string methods that are in Python. These are just the main ones that I thought would be most useful at this point to all of you. So we can run this, and we see that we have false, false, true. Now, remember that these false, false, and true, they're all Boolean values. They're Boolean because there are only two possible outcomes for isTitle, isUpper, and isLower. That's because they check if this is the case, or if they check the case between two different cases, which one is true and which one is false. So basically, isTitle checks there can only be two results from isTitle. It is title formatting, which is true. It corresponds to true, and it's not a title formatting, and so that corresponds to false, and we got false down here. Therefore, the formatting of this string name is not title formatting. And same deal with the isUpper and isLower. Okay. So moving on from the string methods, I think you must have gotten a pretty good grasp on it by now. We can there are also, keep in mind that there are also more, but these are the ones we're going to learn for now. And we can move on from string methods for now and learn about arithmetic operators. So arithmetic operators are just the basic brackets. Exponents is a double asterisk in Python, or double star. The division is just a single forward slash. The multiplication is just a single asterisk or star. And the addition is just a regular plus, and the subtraction is just a minus sign. And those are just the basic math operators. And you can see that if you put in a problem into the print function just to print it out to the console, the answer to it, let's say 5 plus 4 multiplied by 5, you are going to get the answer to this problem printed out to the console down here. Now, the important thing to remember about the computation of these arithmetic operators, sorry, is that they follow the order of operations. So the addition actually follows the multiplication. So the actual answer we would expect from this problem is 4 times 5, which is 20, plus 5 is 25. So we would expect 25 inputted down here. And that is what we got. Okay, so those are the basic arithmetic operators. There's also equal sign and double equal sign. I will explain those more specifically later on when we get into control flow. But basically, a single equal sign is just for an assignment, like for a variable, when you're assigning a variable a certain value. And the double equal is just used in comparisons. Comparison to find the Boolean value of a condition. We'll get into that more specifically later. But for now, what if we want user input? How do you receive user input? Well, that's pretty simple. Uh, there is a keyword in Python called input, and it is a built-in function. Therefore, it requires it's also one that requires parameters in its parentheses. Now, the pretty useful thing about this is that you can store this input, whatever input you get, into a variable. So let's just name this. I'm trying to go into alphabetical order, so D. So D, variable D will is initialized to the input that we are going to receive once the computer actually reaches this line of code, the compiler specifically. So input, you can actually put a string here to communicate to the user and make it easier. So we're just going to say, please enter a number. And whatever precedes this will actually be, this text will actually be printed out to the console. And the user will actually be able to interact with it by means of just inputting a number right after, or just anything really. But we're asking for a number. So what happens is that once we run it, you can see that please enter a number has been printed out here. Now this is not just a regular print. You can put in anything afterwards. So let's say we put in the number 24. Okay. Now you can see nothing actually happened in the console physically, but what happened behind the scenes is that D has been initialized to the value we have just put in. So if we print D, you can see that whatever we put in afterwards, let me just get rid of this, whatever we put in immediately preceding this input statement, I put in 29, you can see that D, we've printed out its value 29. So it has been initialized to that value. So now whenever you reference D, you're referencing that input and therefore 29 in this case.